With a word problem like this, the most important thing is for you to be able to read and then draw a diagram. So we read the question, can we draw a diagram that's represented by everything in this question? And then once we have our diagram, then we can look at the mathematics to solve it. So what do we have here? We've got a support cable anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long and it's attached near the top of the pole. So we get to use our telephone pole drawing skills. Nice. Oh, it probably has like some little things in here. Nice. Well, that looks pretty. There's our telephone pole. Does it look like a telephone pole? I worked on that. You know what? I was up late last night practicing. So I finally got that telephone pole. Now I was like, I'm ready for class tomorrow now. We've got a cable. I'm going to draw the cable in black. It's attached right here. Goes down to the ground. And it is 5 meters from the base, so this would be 5. And the cable itself is 19 meters long, so where would I draw that? Right there in the hypotenuse. It's a support cable. Do you know what a support cable does? Maybe down lower. Maybe I should have been down here for the support cable, not so high up. And then there's the wires. There's the wires going from one to another. And there's a little birdie. That's a little bird. It's a penguin. Anyways. It's a penguin. It's a bird. Have you not seen a bird on a telephone wire? So this is in Antarctica. That's what penguins do. They fly up and go on telephone. Shh. Don't tell anyone that. This is the angle we want to find. What angle, to the nearest degree, does the cable make with the ground? So there's the angle between the cable and the ground. That's what we want to find. The only thing we know so far with triangles is tangent of any angle is the opposite over the adjacent. How long is the opposite side? We don't know. I'm going to put an X there right now because I don't know what that is. How long is the adjacent side? There's only one adjacent. Okay, in a right angle triangle, the right angle would be right here. The 19 is called the hypotenuse. So theta is adjacent to two sides, but 19 is the hypotenuse. The adjacent side is only the 5. So we have a problem. We can't figure this out because we don't know x. So then we have to go, do we have a way of finding x? A squared plus b squared equals c squared. 5 squared is 25. 19 squared is 361. Subtract 25 on both sides. X squared is 336. So we take the square root of that. And we get 18.3. Dot, dot, dot. I'll do that because I don't want to round early until I figure out the whole question. So now I know that it's 18.3 over 5 as my ratio. So if I want to find theta, well, right now I have tan of theta. The opposite of tan is the inverse, tan inverse. So I could do tan inverse on both sides, and I'll say that theta is equal to tan inverse of 18.3 divided by 5. I get 74.7, which rounded to the nearest degree would be 75 degrees. You can solve everything using only the tangent ratio for right-angled triangles. Because if they give you the adjacent side and the hypotenuse like this, then you can find the opposite side by doing a squared plus b squared equals c squared. However, mathematicians over time said, this is getting annoying that I always have to use a squared plus b squared equals c squared. Wouldn't it be nice if we had a ratio that just looked at the adjacent side and the hypotenuse? So they have one for that. That's cosine. What happens if I just had the opposite side and the hypotenuse? Well, we have a ratio for that. That's sine. And we're going to learn those ones as well. But the nice thing in this example is if you used cosine, because cosine is equal to the adjacent over the hypotenuse, well, I have both of those numbers already. 5 over 19. And if I wanted to find theta, what do you think the inverse of cosine is? Cosine inverse. Excellent. So if you did cosine inverse on both sides, you would get theta equals cos inverse of 5 over 19. And if you did that directly, you get 74.7, which is rounded 75 degrees that much quicker. So although we could do everything with tangent like we did here, we're going to learn sine and cosine as well. Because if I had a choice between doing all of the black and all of the green or just doing the blue work is a lot quicker.